Welcome to Congruent Triangles. For this topic, you're going to need to know the 5 congruence postulates and theorems: side, 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 angle, side, angle, side, angle, 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 side, and the 2-letter one, hypotenuse leg. What these look like is side, side, side. The side congruent marks 3 sides. I like to mark an S where I see a side slash. If I see 3 sides congruent to 3 sides, I know I'm using the side, side, side congruence postulate. The side angle side, notice that's a side congruent slash, that's a side congruent slash, and the angle in between. A helpful hint to know which direction to go, I'll show you in a minute after we mark the other ones. Angle, side, angle, this is an angle mark. This is a side slash. This is an angle mark. Notice the curvy ones are for angles, the straight ones are for sides. The angles are also in the corners, the sides are not. This one is angle, angle, side. Notice why. Here's 2 angles and another side. The tricky thing is how to tell the difference between angle, angle, side and angle, side, angle. So let's talk about how we can mark these to know which way to go. So a helpful thing to do is anything where it doesn't have a mark. So here's a corner and there's no mark. I put an X there. Here's another corner that has no mark. And here's another corner that has no mark. All the sides, the non-corners, have a mark at them. It's helpful to put, here's a corner, an X where there is no mark. Here's a side that has no mark, and here's an angle that has no mark. Let's do this for the other 2 pictures. A side has no mark, the angle has no mark, the side has no mark. Similarly down here, here's a side that doesn't have a mark, here's a side that doesn't have a mark, and here's an angle that doesn't have a mark. Or rather, a corner you can think of that doesn't have a mark. So the X's are helpful because we know which direction to go because we can't go over too many X's. So for example, if I start here at the A, I don't want to go this way. It has too many X's, so I stay on the least amount of X route from angle to side, angle, angle, side. Notice here too many X's in this direction. So if I start here, I go to side and then to angle, angle, side, angle. Similarly here, I can't go over all those X's, so I start with one of the S's, side, angle, side. That's really helpful. Now hypotenuse leg, the one that doesn't have 3 letters. So let's again mark here anything that has a side slash with an S, and whatever has a right angle is the same as marking an angle congruent mark, because see, those match. Those have matching angle marks, so those are congruent angles. Here's a corner that doesn't have a mark, also here, and here's a side that doesn't have a mark. So I put X's. So if I follow what we did above, this one is side. I can't go over the too many X's, so I go this way to the S and then to the A. So what that looks like we have is SSA. If I have 2 S's and an A, it has to be side, angle, side. Notice this, if I spell it backwards, looks like this. We never use SSA or ASS. So if we find that we have this, but it's a right triangle, then we can say it's HL. So first I see I have one of these, then I determine, well, I have a right triangle, therefore I know it's hypotenuse leg. The hypotenuse has a congruent mark and one of the legs has a congruent mark. What we know we can mark and the statement that we'll see. 1, 2, 3, 4 important things to remember. Vertical angles. Where are those? You'll see them with the bow tie picture. Lines that cross each other. The angles across are the vertical angles. The statement is what you would see if it's in a proof or in some sort of written information. This is angle P, because see, it says P right here where the vertex is, but we can't just call it angle P because then it's confusing about which angle we're talking about. So instead, we write the 3-letter name, angle QPR, as if we're drawing the angle. The vertex always goes in the middle, is congruent to angle MPL. The vertex always goes in the middle. Notice the vertex is in the middle. There's the P, those vertical angles. This is what we'll see angles congruent, this is what the picture will look like. Statement, picture. Next, alternate interior angles or the zigzag shape. Zigzag means it could look like a Z. The angles inside the Z are congruent. Or maybe it's a backwards Z. The angles inside the Z are congruent. Or maybe it's a Z that's like an N. Any type of zigzag shape gives us congruent angles. Where's the zigzag here? How do I know to go over those lines and not over these lines? The parallel tells me that. See these parallel marks right here? If there are arrows, that means parallel, and therefore I can make the zigzag. Zigzag only over those parallel arrows. So if I have those, again, let's watch. Over the parallel, across, and over the parallel again. I have the parallel arrows. See, it was there to begin with, those parallel arrows. Therefore, I can make the zigzag. Now I know that the angles in the zigzag in the corners are congruent to each other. Again, I can't just use that corner letter B and that corner letter D. I have to use the three-letter name. So what will we see? Angle. B has to be in the middle, so two other letters around the B. Think about how we trace it. A, B, D. A, B, D. B is in the middle. Congruent to, how are we going to trace this one? C, D, B. D is in the middle. There's the statement we would see. Next, corresponding angles or the F shape. Again, here's parallel arrows. So I'm going to trace over just one pair of those parallel arrows to see how we get the F shape. So I'm going to trace over those two parallel arrows. They were parallel to begin with. They had those arrows there. I'm just going to emphasize them. And then I need a line that connects those parallel lines. Here it is right here. Oops, I didn't have to go that far. Let's just go to what it has right there. Do you see the F shape in there? You kind of have to turn your head to the side a little bit, but it's there. If I have an F, the corresponding angles are the angles in the same positions. F can also be turned on its side or flipped upside down. It still gives me those congruent angles. So where are they in this picture? That's right here and here. Angle Z, but we can't just call it angle Z, and angle X, but we can't just call it angle X. So how would we trace it? Z would have to be in the middle, V on one side, Y on the other. V, Z, Y. Congruent to angle, X has to be in the middle. What are on either side? U, X, W. Last one. This one is for the sides, the reflexive property or the shared side. Now I gave you two examples of what you might see. In this first one, you're going to have to kind of notice the two triangles here. One is triangle EGF. I trace over this bottom side. The other one is triangle EHF. Notice both times that I traced over the triangle, I traced over this side right here. Side EF is used in both triangles. So I mark it congruent to itself like that in the picture. How does it look in the statement? Side EF is congruent to side EF. It might even look like, so I'm going to say, or side EF is congruent to side FE. Doesn't really matter the order of how that segment is congruent to itself. The fact is, it's itself, the exact same segment. Shared side, or you could think of same segment. Reflexive, like looking in the mirror, you see a reflection. In the other picture, do you see the two triangles? One on the top, ADC, and one on the bottom, ABC. Both times that I trace the triangle, what side did I trace over? AC, this side right here. So I would mark it congruent to itself. I have to use a slash that hasn't been used yet. And then I would say AC is congruent to AC. Just like that. We're going to encounter some proofs along the way. Here are some helpful hints. Mark what is noted and what you know. See all the stuff we talked about above. Label A or S to the side of each statement. Now that's something we haven't seen yet because we haven't done a proof. That means over here in this area. Finally, you're going to have the option sometimes that corresponding parts of congruent triangles are congruent. That is only ever going to come after the triangle congruent statement. We'll see that in this following example. Use the statement and reasons in the box on the right to complete the proof. So we're going to have to fill them in with these statements or reasons. First of all, it's important to remember that the stuff that's given will always be first. So our choice for given is always going to be what's first. This is given. Okay, the given information always goes first. Notice that matches. This also says given, so that's going to have to go there. GF parallel to HI. Now the parallel arrows are already there. Let's follow the information that they decided to put in the proof. Not just stuff that we know, we have to use stuff that they put in the proof also. So let's look. Angle FGI. FGI. Trace it just like we say it. Then in the corner, put an angle mark. Angle HIG. HIG. In the corner, put an angle mark. So these are angles. Look at the shape that we just created, the zigzag. Do you remember what the zigzag is? The alternate interior is the zigzag. If you see a zigzag, it's the alternate interior angles. So this is our choice here, the zigzag. Reflexive property. Reflexive property is that shared side. Well, what's the side that's shared in this picture? This side right here, GI, congruent to itself. Where does it talk about GI? Right here. Now, I'm not just going to write the letter actually right here. I'm going to write what it has. GI congruent to IG. We'll talk about why in a moment. Now, let's look at what we have. They're about to state that triangles are congruent, but I don't really have everything marked here. Did I mark everything that was stated earlier? Because right now, all I have is one angle and one side mark if I look at just one triangle. Earlier, there was given information, and we didn't put that in the picture yet. So let's take this given information and put it in our picture. Angle GHI. GHI. That's this angle right here. Angle IFG. IFG. That's this angle right here. Now we've marked it. Now remember what we just said. This is an angle. In the side, I'm going to write A for angle. This is a side, but that's not a congruent mark. See, that's a congruent mark. Where do we have another congruent? There's a congruent. And this is an angle. So I'm going to put an A out here. Where do I see another congruent? Here's another congruent, and this is a side. So I'm going to put an S here. Well, read down the list. What do we have? A, S. That's pretty helpful right here. Let's make sure though, because AAS could be the choice, ASA could be the choice too. Let's focus on one triangle and mark A where there's an angle and S where there's a side, and then X's in all the other places. X here, that's not a congruent slash. X here and X here. Now, making sure we don't go over too many X's, we don't want to go this way, angle, angle, side. Just like we saw here, angle, angle, side. Angle, angle, side. Now remember that corresponding parts of congruent triangles will always be the choice to go last. Maybe you make yourself a little note here that this is always last. If it's a choice, you always put it in the last spot. Given, always first. And corresponding parts of congruent triangles, always last. What else goes last? The thing they said to prove. This is our goal, so that's going to go at the very end. GH congruent to IF. Let's look at a couple more examples. Which triangle below is not congruent to the other three triangles? So remember the postulates and theorems that tell us the triangles are congruent. Side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse leg. So we don't see any markings here like slashes, but we do see that all the sides have the same 9 on them. So that's like the congruent mark here. Really, let's just put an S there to think about that side that we all know is congruent. Now there's angles here, a 60 and a 70, a 60 and a 50, 50 and a 70. So it looks like that a lot of them don't match. Let's put markings where the 60s are the same type of congruent slashes, and that's all I see. And then let's put a double slash where the 70s are. 70s, and then we're looking for the same kind of marks. So I see this side mark is here where the two angle marks are on the other side of it, and I'm looking for something that matches that, but really nothing seems to match here such that we have three things for our postulate or theorem. Remember, when we don't know an angle in a triangle, we can always find that because the angles have to add up to 180 degrees. So if I say 50 plus 60 in this one, 110, what do the leftovers have to be? Well, that has to be 70. So finding that missing angle in this one is 70 degrees. So notice the three angles are going to be 50, 60, and 70 because that's what adds up to 180. So in here I have 60 and 70, the leftover one needs to be 50. Here I have 50 and 70, the leftover one needs to be 60. 50 and 70, the leftover one needs to be 60. So the thing to remember is if we don't have an angle, we can find that because we know they have to add up to 180. Let's mark that 50 degree with a 3 congruent slash, and the 60 we already had with a 1 congruent slash, and we're trying to find, oops, that's the 60, that's the 60. We're trying to find the ones that have the matching marks. So I see here this, oops, I didn't mark the 50 over here. Okay, so I see here this S is on the side that has the 1 slash and the 3 slash. This S is on the side that has the 1 slash and the 3 slash. This S is on the side that has the 1 slash and the 3 slash. This S is on the side that has the 2 slash and the 3 slash. There's what's different right there. Not the 1 slash and the 3 slash like the other ones, but the 2 slash, the 70 degrees. So this one is different. This one is not congruent to the other three. Last one. Sometimes we're going to have to figure it out from a coordinate plane. We have triangles ABE, ADE, and CBE shown in the coordinate grid, and all the vertices have coordinates that are integers. Which statement is true? No two triangles are congruent. Only triangle ABE and triangle CBE are congruent. Only triangle ABE and triangle ADE are congruent, or all three triangles are congruent. Well, let's start with examining all three of them and seeing what we can tell about those. And then from there we can eliminate possibilities, maybe go down to 2 or no triangles. So ABE, we'll look at that one first. ABE, this triangle right here. I'm going to trace the three triangles actually to see what they look like to start. A, D, E, and the last one, C, B, E. So tracing them, they're in different locations, they're oriented differently. Maybe some are rotated or flipped, but they kind of all do look like they're the same sizes. Let's look at the shortest side first. In this red triangle from here to here, well, that's exactly the same as this one from here to here in the blue triangle. So we already know that those are congruent to each other by the reflexive property from B to E. Let's count it to see how long it is. So how many blocks does it take from B to E? Remember that we can only count along the lines. So it's 2 blocks in one direction, 1 block in the other direction. So can I count the same from D to E? 2 blocks in one direction, 1 block in the other direction. That's going to give us the same length. So those are congruent to each other. Let's count one of the other sides, maybe the medium length side. So from A to E, well, notice from A to E, that's the same in both triangles, the blue one and the green one. So that's congruent to itself. Let's count how many blocks it takes to go from one point to the other. 1, 2, 1, 2, 3, 4. Let's count how many it is for this side that looks like it might be the same length. 1, 2, 1, 2, 3, 4. We count the same blocks, so it has to be the same length. Let's do that for the third side. So A to D right here, that's 1, 2, 3, 4, 5. And from B to C, that's 1, 2, 3, 4, 5. So this one is congruent to this one, but how about this remaining side? 1, 2, 3, 4 in one direction, 1, 2, 3 in the other direction. Now, this is not just sideways, so I can't just count the blocks, and it looks like I'm getting a different amount. But let's think about it like when we have a right triangle. 4 in one direction, 3 in the other direction. Sometimes we have to use Pythagorean theorem to find that missing side. So from A to B, from this point to this point, will be the square root of 4 squared plus 3 squared, or 16 plus 9, or 25, and the square root of that is 5. So just like we counted 5 in this direction, it's also 5 in this direction. So it is true that all three of these triangles are congruent. We did it!